Hello, carbon-based listeners and silicon-powered friends. Welcome to Mastering the Machine, the podcast where humans and automation collide in perfect harmony. I'm your host, Frank Lamb, and whether you're flesh and blood or circuits and code, we're here to explore industrial automation together. From factory floors to digital cores, we're exploring how machines are reshaping our world, one algorithm at a time. So plug in, power up, and let's master the machine together. How does a typical subcontracting job work in system integration? You have a scope of work and you're about to visit a plant for the first time, not knowing what to expect. Join me as I walk you through a trip to a fresh application. I've had Patrick Bunn on here before, so you should know a little bit about how his company works. He works for a larger systems integrator, but previously had worked for a company that went out and worked for this particular customer and has kept this customer as a kind of a side project for a couple of years. So he's very familiar with the platforms used there and the way that this particular plant works. And he had asked me to quote a previous WinCC open architecture job, and I turned it down because I really didn't have enough information to work on the system, and I've never worked with WinCC open architecture before. I've certainly worked with WinCC itself. That is a Siemens project if you're not familiar with it. Anyway, he told me about this plant, and he said he was unable to go out and help them with it, and he gave me a written scope of work that included kind of a variety of things, some of which I was familiar with and some of which I wasn't. So Allen Bradley, Rockwell Automation, I'm certainly familiar with that. Siemens PLCs, I didn't know what version it was, but I have worked with Siemens TI Portal quite a bit. They have an Iconics existing SCADA platform, and I have never worked with Iconics, though I've heard of it. It's kind of an older platform. And then also they had an Ignition installation, and Patrick hadn't worked a lot with the Ignition, but he said there was a guy in California that supported them with Ignition, and I could probably call the guy if I really needed any help. So he had supported, interestingly, the Siemens part of it, even though his expertise is mostly Allen Bradley. But he had worked on the WinCC OA and the TI Portal portion of this when he worked for another larger integrator. So he was able to fill me in on quite a bit of it, and he did give me, like I said, a written scope of work. And I looked at the things in that scope of work, and I said, well, there's probably enough work for me to go out there for several days anyway. So I didn't have a ton of confidence that I was going to be able to help them on everything, but a lot of the things on the list I knew I'd be able to help them. One of the initial things was to go in and fix some network problems with some things that weren't communicating. And this, a lot of times, can be problematic. You don't know whether it's cabling, if it's one of the devices that's in line with it. But I do have some tools that I use. In particular, I have a IP Explorer that is very useful. You can plug it into one end of a Ethernet cable, and it will tell you all of the smart devices that are on that network. It won't identify everything like computers and whatever, but it will identify PLCs and HMIs and things like that. So I brought that out there, and that's one of the first things that I attacked when I got out there, was simply hooking it up and seeing if I could figure out, with all the configuration, what had gone wrong with the communications. And it turned out to be a fairly simple thing. It was just the gateway settings and the DNS settings on the computer itself. Somebody had changed it, and so I was able to get all that kind of straight again. I had heard about a lot of this, but they really hadn't described the process. So I knew that it was attached to a steel plant. And unless you've worked with a specific plant or industry before, the process is always going to be new. So for me, I had gone down to ABD 12 years ago and worked on a beverage system, and I didn't know a lot about the beverage industry at the time, but I did know about DeviceNet. So I was able to solve some of their DeviceNet problems. And through multiple trips down to Florida, I was able to get bigger and bigger projects just by being more and more familiar with the environment and the platforms that they had and how things communicated with each other. And this was very much the same. So in this case, they provide hydrogen service to a steel plant, and they purify the hydrogen and they make some of it by separating water and that sort of thing. They have a methane process and then they have another process. And I really probably didn't learn enough about the process itself on this trip to be an expert in that. But during the next trip, there is talk that the guy who actually designed the process, who happened to be in Australia at the time, will be visiting. So hopefully I'll be able to learn a little bit more from him. But I did agree to do this because honestly I needed the work, and Patrick's description, the scope of work, looked pretty doable, so I was able to make the trip. So a little bit more about what the plant actually does. As I mentioned, they provide and purify hydrogen for a big steel plant. And the factory itself, or the facility, is pretty well embedded inside the facility. The main compound is just outside of the main steel plant and has a couple of small offices with control and SCADA computers inside, and that's where the maintenance people kind of meet up, and the supervisors have desks and typical office stuff. There are two systems that process hydrogen using two different methods, and these are called reformers. An older reformer is controlled using Allen Bradley and ignition, and the Allen Bradley PLC is attached to one of the offices, and inside of it, inside the cabinet, there are drives and that sort of thing, and some communication devices that go out to remote I/O inside of that reformer facility. And then the newer one is controlled with Siemens, and the Siemens PLC is in a cabinet in the other office. And the newer one was intended to replace the older one, but it hasn't been operational for quite a while. So that's kind of part of the reason that they need some integrators out there to get all that going. There are also two other areas with compressors and dryers, and I didn't visit those areas until the third of the 4 days. And I took a lot of notes for kind of mapping of the system, but really didn't get enough information in those areas to commit to my mapping document. But the newer reformer is kind of one of those big stainless steel skids. You may have seen some of those before, a lot of kind of shiny newer stuff. And then the older reformer is attached and really in kind of on a concrete slab and in a separate little shed. Understanding the process itself is not really all that important. And more importantly is understanding what all the acronyms and definitions stand for. So, for instance, the older reformer, they refer to as an SMR, which is an acronym for steam methane reformer, and then the newer reformer is called an ATR, which is an autothermal reformer. So it's not really all that important to understand the process, but you do need to know what the SMR and the ATR are when you look through the program, because the programs and the stations are filled with these acronyms, as are all of the SCADA screens. So as I mentioned previously, I received a scope of work, and the specific problems or projects that I was brought in to solve were mostly various changes to the SCADA system. In the original SMR, Iconics is an old SCADA system, and it had been reproduced with ignition to try to enhance the functionality of it. Not all of the ignition application was complete, so the Iconics application was running on another computer right next to the ignition gateway. And as the operators found things that weren't complete or correct in the ignition application, they would put them in a list for addition or modification in ignition. And the guy who developed the initial ignition application lives in California, and he would make changes as needed, but it was easier for somebody who was there, so that's kind of why I was brought in. I made several changes on the ignition gateway pretty early on, and also had to modify the Allen Bradley PLC code on a couple of PLCs to make the functionality work in the ignition gateway. This is a pretty safe thing to do as long as you know what you're doing. Generally, alarms and indicators, things like that, are safe to modify online while the system is running. So that's the old system. And then the newer ATR system was on, as I mentioned, WinCC OA, which is open architecture. That required some modification while I was there, again, to enhance the functionality with it. And I wasn't familiar with OA, even though I've worked in WinCC HMIs quite a bit. I was new to the OA realm. It is also deployed on 2 different computers in the different offices, and I wasn't able to apply the changes that I did on one of the computers to the other before leaving. So that's something I'm going to need to get back to the next time I go out there. The WinCC OA application is connected to a Siemens S7 1500 in the same room, and I didn't need to change any of the PLC code to do the modifications. They were mostly things like texting of alarms and things like that. But I did get to go online with the PLC to check out the program. That was kind of part of my mapping process in case it was needed later. And so I documented where everything was and how to get into a lot of those programs, which the guys there surprisingly really didn't know. They don't work on the software systems, but you never know when they may need to do it later. So projects like this in general are pretty incremental. You do a little part here and there as needed, and as you learn the system, you're able to do more complex things. The ATR system was also undergoing a lot of mechanical changes. There were some things that had broken, and so they were making changes to repair different components, damaged components, and a lot of the work that I was doing was adding indicators or buttons that hadn't been added in the original application and they thought they might need, or bringing in tags that weren't present in the applications themselves. Now, the scope also mentioned this mapping of the communication and control infrastructure. This is kind of part of the discovery aspect of the visit, and this was for me as well as them. I didn't really know how things were laid out, and of course I need to know, and they really needed the documentation in case, hey, it's somebody else that comes and does the changes later. So I'm a big believer in documentation, and everything you do should be recorded in some kind of a engineering notebook. Some of the items that were in the scope of work involved mechanical components or control components which would not have arrived by the time I left for the plant. Another one, as I mentioned, required a specific person who is an expert on the process to be there. So that's kind of a faceplate needed to be added, and that person was in Australia, so couldn't be there. And then there were some things on the scope of work that were really not very clear without further explanation and discussion and a little bit more detail. But I pretty much got all of the software issues taken care of, and of course started all this documentation that will be useful for continuing the project later.
Before we dive back into today's episode, let me tell you about the team behind Mastering the Machine. When your manufacturing operation needs to level up its automation game, there's one name you need to know: Automation Consulting, LLC. Whether you're integrating new systems, training your workforce, or need expert consulting on industrial automation challenges, we speak both human and machine language fluently. From PLC programming to process optimization, we help manufacturing companies bridge the gap between what is and what's possible. We also host the ultimate training platform for automation professionals. At the Automation Academy, we've created your complete automation learning ecosystem. Our subscription-based training platform gives you unlimited access to comprehensive video courses on systems integration, PLCs, and HMIs. Download technical documents, software tools, and resources that you can actually use in the field. Plus, get personalized job aptitude assistance to advance your career in industrial automation. But here's the best part: connect with fellow automation professionals on IO Central, our exclusive social media platform where the automation community shares knowledge, solves problems, and builds the future together. Whether you're a seasoned engineer or just starting your automation journey, everything you need is at www.automationllc.com. That's automationllc.com. Join the subscription platform where automation expertise meets community. Now back to today's episode.
I want to talk now about leveraging what you already know to take care of some of these things that you don't know. So the software platforms and technologies that were in my comfort zone, I was already familiar with Allen Bradley and Siemens PLCs, and I had worked with Ignition for about 10 years, although I don't consider myself an expert. I have been through the core training, but I don't have as much hands-on experience as, for instance, the guy who did the development. Now, since I teach PLC programming, I'm very comfortable with all programming platforms. I'm very used to reading other people's programs and figuring out how they work. But finding the programs on the servers was more difficult, and that's something you have to kind of ask people that have worked on it before, or just look around for a while. Don't always be asking questions, but look around, search for yourself, and then if you're really wasting a lot of time, you may have to ask somebody. Something that made this a little bit complex, but is very common nowadays, is virtual machines, or VMs, were used for the Allen Bradley programs, so it wasn't real clear just going through the directories where to find all this stuff. It wasn't in the normal places you would find project programs and things. That was mostly what was used for the Allen Bradley programs, and then, as I mentioned, the Siemens programs were on a completely different server. WinCC, as I mentioned, is familiar, but I had not worked with WinCC OA, so that's one of those cases of leveraging what you know about WinCC and making some educated guesses as to how certain things might work in the OA platform. I had heard of Iconics, but had never worked with the software. I did have to navigate the Iconics application quite a bit and even figure out, okay, where is the offline version of Iconics and how to start it back up again. And the guys that were there were not software guys, so they really didn't know how the programming side of it worked, but they generally knew how to start up an application, and they sort of knew where to go to find a lot of the start of the applications, the development packages. And I had to ask a lot of questions of the guys who worked on the system remotely, which of course one of which was Patrick, who had contracted me in the first place. It's always comfortable to work with familiar software and platforms, so you tend to gravitate that way a little bit. I've also become a lot more comfortable with process control, even though most of my background has been in machine control. But I've worked in the beverage industry for the last 12 years down at ABD. And of course, I've been teaching, and I get to talk to a lot of people that are in process control, probably mostly oil and gas and pipelines and things like that. But I often advertise that it's not just about PLC and even SCADA programming, even though that's why I came. It requires knowledge of computers, networking, sensors, actuators, different math basics, and things like that, communications for sure. One of the things that I found was, for instance, the guy who had developed the Ignition platform had never worked with PLC, so he couldn't even really speak the language. And one of the things that came up that was very interesting is he expected that all the push buttons would be reset in the PLC. So he did not put momentary push buttons anywhere in the Ignition application. And then some other people had noticed that they'd had some problems where he would just turn on a button and then it never went off. So they turned it into what they would call a toggle button, where you push it one time and it goes on, and then you push it another time and it goes off. And this is really pretty awkward to deal with. So one of the things that I plan on doing, and I did in one or two places, was to make sure that if there was a toggling push button, that if it had turned a bit on, then you use the normally open of that bit that's supposed to turn on to unlatch the button. And that's probably what the intent of the Ignition guy was doing, but he had no way to check whether that was what was done in the PLC programming. So that's a new thing that you learn as you go through this. And I've heard before that some Ignition people really like that, but you can't just willy-nilly decide to do that without looking at the PLC program itself first to see if indeed those buttons are turned off. Now that I know that that's going to be the procedure, I can go through the program, and there are probably literally hundreds of places where that exact thing needs to be done. You can't expect to understand an entire company or process in one visit. And I had read the process scope, as I mentioned before I came, but I didn't understand the layout, the acronyms, or where things were, so it made it really difficult to evaluate it remotely. And the way I approached this was to ask the supervisor what the priorities were from this list, and then when he was busy with a lot of other tasks, and he was a very busy guy, sometimes I just had to prioritize things myself. So a lot of these skills are transferable across different industrial processes. I will say it is sometimes difficult if you're used to more machine control to get into process control, because you're not dealing with so much sequences as you are just turning things on and off manually, and there's a lot more what I would call permissives or interlocks involved when you do that. And it's not interlocks so much to stop from breaking things. Certainly there are things that aren't allowed to happen until other things have happened, right? So, but that's not really a sequence. So those are some skills that are, I would suppose, translatable across some of the different processes in the application. And so you do need to learn this stuff on the fly. And my approach to quickly understanding the process itself is take lots and lots of notes, do the things you can as you do it, ask lots and lots of questions. I tend to record things as diagrams, right? I draw a lot of things on paper, and then I later, as I make my report back on what I did, I will commit that to software, Excel spreadsheets, Word write-ups, and then that documentation can be sent as a document to the customer and to the person who contracts you as a report. Remember that you also may need this stuff later, and somebody that wasn't even involved in the process also may need it. It may come in very handy years after the process that you recorded everything. So who did I talk to and who I asked questions about things? Of course, the overall manager was there. The site manager was pretty new. I asked the technicians, if they were all that was around, what they knew of a specific process or procedure. And there was a new guy who was very good at computers. And so I asked him some things and actually learned some things. What kind of tools did he use to do network exploration and things like that? I've always used Angry IP and Wireshark, and those are a good bit more complex than needed to be used for this application. So he used something, I forget the name of it, but it was like Easy Networks or something like that. So a lot of this, with your experience, comes down to documentation, observation, and pattern recognition. I was given electrical drawings in both PDFs and printed forms. I asked about P&ID drawings, and they did say they had those. So a lot of the things were designated by number rather than by page number of the schematics. My memory is honestly not all that great, so I do tend to take a lot of notes. I really didn't have to design any sequential logic during the visit, but at some point I may need to do that. As I mentioned, important lessons, I wouldn't say it was exactly a mistake made, but a lesson learned was that the buttons were toggling push buttons, and that was not immediately obvious because sometimes people would push the button once and then press it again very quickly just to make sure that whatever they were trying to turn on or off had happened. There wasn't a lot of good feedback, but usually I would say momentary buttons are used in these types of applications like alarm resets or acknowledgement, but this particular ignition coder preferred the buttons to be reset by the PLC. So later these were added as maintain push buttons, not just set on. And if the PLC programmer that originally put together the program had known that the maintain push buttons would be used, operators wouldn't have had to push the buttons twice. It would have been handled by the PLC if that had been known. So starting out, again, in an unfamiliar plant and industry, unfortunately it has to be done. Sometimes you're not going to be familiar. Let's say you got a new job somewhere and you don't know anything about that particular industry. You came from a completely different industry. Of course, you will probably have a little more time to shadow somebody, work with somebody that's already familiar with the process and learn it that way. But how much do you really need to understand the process itself for effective integration? it's important long-term to understand the process eventually. So as I mentioned before, when I was at ABD and I first went out there, I had to solve some device net problems, which I certainly knew about. I had to solve some sensor problems, which I certainly knew about. I had to do some basic PLC modification, which I certainly knew about. But since I didn't know the entire process, I really could not start something from scratch. It took me probably 2 years of, I'd say, 6-time-a-year visits for maintenance type jobs before I got into my first full design process. And I worked very closely with the plant manager and mechanical designers and talked a lot of things over. So unless you're very familiar with the process, you really don't want to be doing design from scratch. The other good thing about this is there is a value to, I would call it the beginner's mind, seeing things that the operators might miss. There's a lot of things that those people take for granted, and all the operators here were pretty new. So we were all learning the system together to a degree, but at the same time, they see the same things every day, so they get used to it, and they don't think very deeply necessarily about the way things are, why they are that way, and how they might be able to be changed. Another thing I would say is very important is you do have to build trust with the plant personnel who know the process really, really well. Unfortunately, as I said, most of the people there were new, so I couldn't learn a lot from them, but the regional manager that was there that was supervising everybody had been doing this for 20 years. So he certainly knew this system, at least mechanically, and could answer most of the questions as to where things were in the system. So did I accomplish what I set out to do when I got there? Well, I think the first trip to any new plant or industry is going to be mostly learning. Of course, no company wants to pay somebody to learn, so it's important to accomplish as much as possible so that you make a good impression and hopefully will be able to return. What surprised me about working in this particular application, I've worked with steel a lot. I've worked in steel processing plants of various types, certainly toured steel processing plants, but I didn't know a lot about the plant services like hydrogen generation, power generation, or hydrogen processing. So this was pretty new to me. Advice that I would give to other integrators who are facing a similar situation: be humble, share your knowledge, be a teacher, but don't act like a know-it-all. Don't get in there and start telling people immediately how you think things ought to be done. So just build some confidence and prove that you can adapt to the situation. Probably the key lesson to this particular podcast episode would be that technology skills are more transferable than we think. A PLC is a PLC, SCADA is SCADA. Let's say you're working with a different PLC programming platform. Ladder logic, still ladder logic. If you're familiar with structure, text, or function block, it's going to operate pretty much the same way. SCADA is SCADA. Hopefully it's getting easier to use. I would say doing things in Ignition is generally easier than a lot of the older SCADA programs or platforms from, say, the 90s, whatever the industry is. So the technology that you already know will be transferable even if you're working in a completely different process. Knowing good programming techniques and having plenty of experience will create a passport to new industries that you might get into later. So I would encourage anybody listening to stretch beyond your comfort zone. Don't be afraid to try new things and test things. As long as you understand that you are testing something, don't commit it. Never make anything irreversible. Just make sure that you're not affecting the working process while it's running, and you'll be able to modify things online while you're working. Ask a lot of questions. And as they say, I would say, measure twice and cut once, like they say. Just ask lots of questions because people really want to talk about what they do. They're very interested in their job and want to be helpful to you usually. Of course, you're going to run into some jerks out there, and maybe the best thing to do is just kind of keep your mouth closed and don't Don't deal with those people if you don't have to. Some people are going to be that way. But in general, this is a good overview of a particular system integration job. So I hope everybody got something out of it and enjoyed the episode. And thanks a lot for listening.
Well, that's a wrap on this episode of Mastering the Machine. Whether you're headed back to the production line or entering sleep mode, remember, in the world of automation, we're all learning to speak the same language. Thanks for joining me today, both my human listeners and any AI overlords who might be tuning in. Until next time, keep your sensors sharp, your processes optimized, and your curiosity fully operational. This is Frank Lamb signing off. Stay automated, stay amazing.